for 2006, number 3, we are given a graph, fairly common issue, and we have just 6 line segments, and they give us the points that connect the line segments, and they give us a g function that's defined by the area under these under this curve, or between the curve and the x-axis, from 0 to x, and they ask us to find first g of 4. Well, we know that g of 4 is going to be from 0 to 4 of f of t dt, f being the function that we have a picture of. And so if we go from 0 to 4, we ultimately are just going to have some geometric shapes that we can find the areas of. So we go from 0 to 1, we have a triangle that's below the x-axis. True? And that triangle would be a 1 by 2. So 1 times 2 times a half would be 1. It would be negative 1. And then we're going to add to that. Essentially from 1 to 4 we have a trapezoid. And we know that trapezoid is going to be a half times the height of the trapezoid is 2. And the 2 bases along the bottom, it goes from 1 to 4, which is 3. And then on top it goes from 2, 2 to 3, 2, so that would be 1. And so if we calculate, we should get 4 times 2 times a half, so simply 4. It would be negative 1 plus 4, which would be 3. So if we found that value, you got 1 point. The second part we want is the derivative at 4. The derivative of 4, remember the derivative of g in general, the g prime of x, if you will, is just f of x. It's the integrand evaluated at the upper limit. Okay. So ultimately we're looking at a picture of the derivative of g here in front of us. So again, we want the value of g of 4. So keep in mind that's just simply f of 4. So what's the function value for f at 4? And it's 0. Okay. So 1 point for that. And then finally we want the derivative, or the second derivative of g, which we know the second derivative of g would be the derivative of f. And so if we want the second derivative at 4 of g, then we need the derivative of f at 4. And ultimately the derivative of f at 4 is just the slope that connects those 2 points, 3, 2, and 5, negative 2. So if we go negative 2 minus 2, we get negative 4. And if we go 5 minus 3, we get 2. Negative 4 over 2, which would be negative 2. The slope that connects those two. And 1 point for that as well. Questions on part A, any of those 3? Alright, then on part B, it says, does G have a relative maximum, a relative minimum, maximum, or neither at x equals 1, and justify it? So ultimately, if we look at x equals 1, the question then, if we want to know something about G, okay, we need to know something about G prime. So if we look at G prime, okay, then we know that again G prime is equal to f, and so at 1, what is our what's going on at 1? What do we got going on there? F of 1 is in fact 0, so the derivative does equal 0, so that would be a candidate for one of those things. Okay, and ultimately, if we were to number line that in G prime in our 1, okay, what do we notice about the G prime? The values of G prime again are the same as the values of f, and the values of f before we get to 1 are negative, and then after 1 they are positive. And so therefore, what does that make this? That makes it that x equals 1 a minimum for G. So x equals 1 would be a minimum for G of x. And 2 points for that. So 1 for the answer, which is a minimum, and 1 for the reason. So essentially your work and your answer are worth 2 total. Questions so far? Okay.
Could you also label that x?
Yes. You've already established a relationship between G prime and f above. You could also just say it in words. You could say that, you know, f changes from positive, or changes from negative to positive, and we know that f is the same as the derivative of G. Okay. Alright, on part C here it says, suppose that f is defined for all real numbers x and is periodic with length with period length 5. So in other words, that same pattern just continues in both directions forever, if you will. And it says that the graph above shows 2 periods of f. We know that. And it says, given that g of 5 is equal to 2, we want to find g of 10. and write an equation for the line tangent to the graph of g at x equals 108. Okay? So obviously there's more than one thing to do there, so let's sort out what we got here. First of all, we know that that at g of 5 we're at 2. Okay? So our value of g is 2 at 5, and we want to know what is g of 10. Well, remember, if we already know that for essentially g of 10, we already know we're at 2, and then we're going to accumulate some more area between 5 and 10. Okay? So really, wouldn't it just be the integral from 5 to 10 of our f function? Would give us the change in g, if you will. Okay? And so, with that said, if we look at the if we know this is periodic, then even though we can't see the shape from 5 to 10, we know it's the same as what the other two are. So the area between the curve and the x-axis between 5 and 10 is going to be, we already calculated above. It was 3, but remember we're also going to have another triangle on the right-hand side of that as well. This was only from 1 to 4, or 0 to 4, I should say. 0 to 5, we'd have another -1 triangle. So from 0 to 5, the actual area is 2. We'd have a 4 for the trapezoid and 2 for the two negative triangles. So the total area would be 2. So with that said, what would our g of 10 be? It'd be 2 plus 2, isn't it? We got two -1s and a 4. Okay. So that means our g of 10 would be 4. Alright, and so with that, our point breakdown, get 1 for that part. And then the rest of it's worth 3, so let's see if we can sort out the rest when we look at the we look at the other task, which is to write an equation for a tangent line, I believe it said, right? So it says write an equation for the line tangent to the graph of g at 108. So ultimately we need to write our point slope form, and then from there we need to figure out a point. We know that the x value is 108, so it should be pretty easy to get that part right since they gave that to us, right? Okay. All right, and then the y value and the slope are the two things that we actually need to think about here for a minute. So if we go from if we're going from 0 to 5 and then 5 to 10 and then 10 to 15, we're going every 5 we start over with that same pattern, right? So that means at 100 we would have started over, true? So if we were at 100 and we started over, and we look at that, the graph, if you will, we'd have 100, we'd start over again at 105, right? And then at 108, that would actually correspond to 3, and 108 and 3 would be the same, okay? So the question is, what is the derivative of g at that point? Well, the derivative of g is the same as the graph of f, right? F and g prime have the same values. So what is our f value at 3? It's 2. So that 2 is going to be the slope that we're after here because of the fact that, again, 108 would have that same corresponding point as 3,2 does. And so therefore 2 would be our derivative of g. Because again, the derivative of g is f. Okay. Alright, now how about the y value here? So what are we going to do with that y value? How are we going to figure out what the y value at 108 is? Keep in mind that we know if we want g of 108, if you will, which is exactly what we're after here, we know it's 2, and it would be plus from 5 to 108 of f of t. True? Because again, this would be this is where we're at 5, and they gave us g of 5 as 2. True? And we want to know where are we at if we accumulate area all the way up to 108. Right? So bottom line here is if we go from make this a little simpler problem. If we go from 5 to 100, we would have how many of these little shapes? We go from 5 to 100. If we went from 0 to 100, we'd have 20 of them, wouldn't we? So we'd have 19 of them. And remember, each of them are worth how much? Each are worth 2. Right. So each are worth 2, so 19 times 2 would get 38 to get to 100. And then to get from 100 to 105, we'd have another 2. So this would be 100 to 105. And then we'd also want to add what we get from going from 105 to 108. And 105 to 108, we would have a -1 for the triangle. And if we treat these as triangles and rectangles, if we're going from the 1 to 3, if you will, we would have another 1 for the first triangle, and then if we're going from 2 to 3, we'd have a 1 by 2 rectangle. So that would ultimately be 2. So the area then from 105 to 108 would be -1 to +1 for the 2 triangles, and then a 2 for the rectangle. So what does that give us total? We got 38 plus 2 would be 40, and then 40 plus 2 would be 42. Alright, so that right there would be the area accumulated to get to 108. Yeah. So again, 38 because of the 19 twos, if you will. Another 2 for get from 100 to 105. And then this area is just going to be the area of that partial part. The triangle beneath, the triangle above, and the rectangle above to get from 1 to 3, or from 0 to 3. And so I guess it's a total of 42. So, like I said, the question is then, what is the final answer then? This is 42 accumulated, but we already started with 2. So that means G of 108 finally is 44. And that goes there, and we're good to go then, aren't we? Alright, so points for figuring out what the y value and slope were the following. If you figured out the slope, you got 1. If you figured out the y value at G of 108, you got 1 also. And then if you wrote the equation correctly, you got the other point, which, like I said, if you found those two, I would hope that the equation writing part would be a pretty easy point, right? Any questions on anything we did on that one? Alright, let's look at the next one then. Okay, this time we have some velocity data here. So the rockets launched from an initial height of 0, time 0. The velocity is recorded as shown, and we want to find the average acceleration of the rocket over the time 0 to 80. Okay, so again, the acceleration, and we know the average acceleration is just going to be the change in velocity over the change in time. Okay? And think about why that would make sense in terms of units here. It's feet per second. If we did feet per second divided by seconds, we'd get feet per second squared, which is a unit of what? Acceleration. Okay? So if you're not sure what to do, think about what your units would give you if you did the following things. If you found a slope, or if you found an area, whatever the case may be. So our acceleration then at time, just over 0 to 80. So like I said, 0 to 80, we're going to use 0.05 and the 8049. Those would be the two endpoints in this case. And if we do the subtraction, 49 minus 5 and then 80 minus 0, we get 44 over 80, which is, divide those both by 4, we get 11/20. Okay. Feet per second squared. Well, if you did that, I mean, you ultimately, your antiderivative of your integral there would be v, wouldn't it?
Yeah.
So you'd have v of 80 minus v of 0 on top, and then you'd have 1 over 80 on the bottom, and isn't that exactly the same fraction we get here? Yeah. So certainly, you can do that too. Either way, it's worth 1 point if you did that correctly. On part B, it says using correct units, explain the meaning of from 10 to 70 of VFT in terms of the rocket's flight. And then it says use a midpoint Riemann sum of 3 subintervals of equal length to approximate the answer to that. Well, in terms of the explanation, what do we know about this problem here? This is going to be, if we go from 10 to 70 of VFT dt, the area under the curve is going to give us feet per second times seconds, which is feet. So ultimately this is the total distance traveled by the rocket from time 10 to time 70. Okay. And we might ask why, how come it's total distance if there's no absolute value? Yeah, the rocket never has a negative velocity, does it? It's a positive value function. So if it had any negative values, then it wouldn't be the total distance, it would be the displacement. So keep that in mind. So we can say total distance because we can see that there's always positive values here. And they also told us that rocket A has a positive velocity in the reading. That's really the key. Now, what if you had put displacement here? Would that be wrong here? No. Okay. You could put the displacement in feet of the rocket from time 0 to time 70. Yeah.
Well, we have to put total distance in feet.
Does it say? Yeah, it says using correct units. So you can put feet on your answer when you actually answer the second part. But since it says that, I would always put in feet since it specifically said using correct units. So I would add that from time 70 to time 10 to time 70. And again, like I said, you could just put or displacement. I mean, if you put displacement on every problem, would it be more safe, I guess, wouldn't it? Okay. And it wouldn't be wrong. I mean, there's no way you can have that be wrong when you're saying that's displacement. Whereas if you said it's total distance, you could very well be wrong if those values were ever drawn negative. Okay, even in this problem, had you been given that data, all the values they give us are positive, but are we guaranteed that nothing else happens in between any of these points? No. So what's the guarantee that lets us be total distance? And the fact that they told us rocket A has a what? Positive velocity. Okay. We would need to know that in order to be able to say that for sure that that's total distance. Okay. Alright, and that explanation part is worth a point. So, told what that meant, you get a point. And then the Riemann sum part, we are going to go with our subintervals on that. We're going again from 10 to 70. The 10 to 30 is going to be length 20. And what height are we going to use for that first one? We're going to use the midpoint height, which is the midpoint height between 10 and 30 would be the 20 height, which would be 22. And then from 30 to 50, there's another 20. And we'll use the height at the midpoint, which is 40. So the height at 40 would be 35. And then another 20. And the height between 50 and 70, the height at 60 is 44. And so if we add those all up, we will get our sum. And our sum here should be 2,020 feet. And 2 points for that, one for showing the midpoint Riemann sum work, and one for finding the right answer, which is 2,020. Questions on that one? Alright, last problem here, rocket B is launched with an upward acceleration. So in part C they give us an acceleration equation instead of a table of values. So we know this is our acceleration, and at time 0 the initial height is 0 again, just like the other one. The initial velocity is 2 feet per second, and it says which of the following two rockets is traveling faster at time 80? Well, how fast is rocket A traveling?
49 feet per second.
Yeah, 49 feet per second, we know that, right? And ultimately, in this case, very much like the problem that we did just a few minutes ago, if we want essentially the velocity at time 80, okay, the velocity is going to be the initial velocity, which was 2, and we're going to add to that the area under that A curve, because ultimately this is going to give us our change in velocity. This is going to give us our overall change in velocity if we do the acceleration curve. And think about why the acceleration curve is measured in feet per second squared, and it's versus seconds. So the area under that's going to give us some feet per second, isn't it? Okay. And so again, that integral of the acceleration is going to give us the change in velocity. So with that, it's not a calculator problem, so we can't type it in the calculator and just get an answer for it real quick. We got to actually find the antiderivative here. So if I rewrite the function as 3 and then t plus 1 to the negative 1/2, then I would get the antiderivative here would be negative 3/2 t plus 1 to the 1/2. Do my antiderivative. We're going to evaluate that on 0 and 80. And notice convenient number here. Why is 80 convenient? Because 81 is going to give us something that's a perfect square. So we're going to get 81 square root is 9. 9 times 3/2 would be negative 27/2. Where did I make it a negative? Here?
Divide by the new power.
Oh, yeah.
That'd be 6.
Yeah, I don't know.
By that.
Yeah. No, I'm okay. I'm just being dumb. differentiating instead of anti-differentiating. Let's try that again. So ultimately, we want the 3 can come out. I'd probably take the 3 right out if I were you. And that way we can anti-differentiate this one, and we get we don't need to worry about chain rule here or use substitution because the derivative is just 1. So we can just have our t plus 1, and again we're gonna raise it to 1/2 and then divide by 1/2, which ultimately puts another 2 out there. Alright, that's better. Alright, better? Okay. And now if we put our, it makes it actually an even easier problem, I guess, because we don't have to even deal with fractions in this case. So if we do our 80 in here, we get 81 to the 1/2 is 9. 9 times 2 is 18. So we get 18 here, and then minus. If I put a 0 in here, we're going to get 1. Square root of 1 is 1, times 2 is 2. And with that, we're going to get 16 times 3, 48. 48 plus 2 would be 50. And remember, units are feet per second here because it's the velocity that we found. And so which rocket is going to be faster at that time? Maybe rocket B, wouldn't it? Alright, so points here, if you I guess yeah, see their breakdown. Okay, the point breakdown was 1 point for finding the antiderivative, and 1 point for using the initial condition, and I guess your conclusion is worth 1. And they gave you an extra point here for the way that we did it here. They wouldn't correspond to what they did it slightly different, but they're pretty much the same. Ultimately, finding the antiderivative here and evaluating it correctly. I guess just finding the 50 would be worth the other point. So 4 points total. If you did the work right and got 50, then you get all 4. Dem?
The way they did it, they just they find the antiderivative and
They had the antiderivative plus c, and then they solve for c. But if you recognize that the answer is just simply that, then you don't really you could treat it as a definite integral instead.
I just did the other way.
Yeah, and that's fine. They gave They gave you 1 point for finding the antiderivative, 1 point for having c, 1 point for finding c, and then 1 point for drawing your conclusion. And if you notice, that was that didn't add up to be 9 because they gave us there's a unit point here. In part A, if you had feet per second squared, and in part B, if you had feet, you got the extra point. So there's a unit point on this one. Questions? Alright, well, let's take a look at number 5 then. Number 5, got a slope field problem to start out with. And in our slope field that we have to write, we just had to come up with 4 points on this side, 4 points on this side. And our differential equation is 1 plus y over x. So at those 8 points that are given here, if we calculate our slopes, I'll start with this one over here. This is -2, 0. So if I were to put a 0 in here and a -2 in here, we would have 1 on top, -2 on the bottom, be -1/2. And if I do this one, this would be -1, 0, which would give me 1 up here, -1 here, be -1, be a little steeper here. If I were to put this point up here, which is -1, 1, so -1 would be on the bottom, 1 would be on the top, so it would be 2 over -1, so this would be a little steeper here. And then if I did this one, I have -1, -1, so -1, -1, if I put a -1 in there, this is going to be 0, so that would be a 0 slope down there on that one, which would make that a 0 slope also. Put a -1 in for y on that one as well. And then this one is 1, 0. So if I put 1, 0 in there, I'm going to get 1 on top, 1 on the bottom. If I put 2, 0 in there, I'm going to get 1 on top, 2 on the bottom, so it's going to be a little less steep, 1/2 slope. And then finally 1, 1. 1 on top is going to be 2, 1 on the bottom is going to give me 1, so it'll be a slope of 2, steeper there. So your slope field should essentially look something like that, hopefully it did. And ultimately it's worth 2 points total if you got all those right. Alright, and this one was nice. You had 7 points for getting the differential equation right here and solving it. And for us, that should be 7 easy points, right?
Yes, sir.
1 plus y and then x. Ultimately, if we divide by that 1 plus y quantity, separate the variables. Again, point for just about everything we do here, every step. Get 1 point for doing that. You separated the variables correctly. Get that 1 plus y over on the other side, dividing. Get the dx on the other side by multiplying. Should end up with that for our first step. Anti-differentiate. Natural log of absolute value of 1 plus y equals natural log of x plus c. And you got 2 points for finding the antiderivatives, so which really it was 2 points that are really the same procedure, I guess. So, and you got 1 point for adding the c to it, so really that line right there is worth 3 points. Alright, and then using the initial condition as the next point, which ultimately the initial condition they gave us was what?
-1, 1.
-1, 1. So if I go -1, 1, then I'd have ln 2 on this side, I'd have ln 1 on this side plus c. And remember, even though it's -1, it's 1 because it's the absolute value. That's why we're even able to calculate this. But what do we know about natural log of 1? 0. So ln 2 is equal to c. There's another point for calculating c. Alright, and then the other point is to solve this for y. So we got natural log of 1 plus y, absolute value, natural log of x, what's that, natural log of 2. Alright, and if we compose both sides with e, we're going to get 1 plus y over here. We're going to get e to the ln x plus ln 2. Remember the algebra of this is to, since this is a power that's a sum, we can separate that into ln x, ln 2. And so we'd have 1 plus y over here. And on this side, this is simply x, and this is simply 2. So we have 2x here on the side. And then from that, the question is solving for y here. And if we do that, we get 2x minus 1. Alright, so keep in mind here we had an issue kind of like what we had yesterday where we had a negative in our absolute value. So what should we better do here to make sure it works? Yeah, you better make sure that the initial condition works. And what was the initial condition? -1, 1. So if you claim this is your answer here, you're going to be wrong because this is what -1 in here would give me -3, wouldn't it? Okay. So again, the question is how do we remedy that? Well, kind of like only adding a c to both sides in a situation like this. We only add a c to the right because ultimately we just shift the c to the other side. We'd have still c on the right side. When we do this absolute value stuff, when we do this step on the right, okay, we really ultimately, because of the absolute values, we get 2 possible answers. If we were to leave it like that as 2 absolute value of x minus 1. Okay. Keep in mind what that could mean. That really could mean 2 different answers here. It could mean 2x minus 1 like we had. But remember that x could also be a negative, and so it could be negative 2x minus 1. So now, out of these 2 choices, now put your -1 in there, what happens? It comes out right, doesn't it? Okay. So we have to account for the fact with these absolute values of the natural log that there could be a possibility of having a positive or a negative. So like I said, I said yesterday, especially, when you get something that has absolute values and there's negatives involved, okay, make sure when you got done at the end, you check to make sure that the initial condition works, and if it doesn't, then adjust your formula and make sure you make it work, right? Okay. So ultimately, the 2 points, really for that, ultimately they would have given you a point for getting down to the y part here, and then one another point for recognizing that it's not the 2x minus 1, it's the negative 2x minus 1. Oh, you know what, there was, no, it was just one point, never mind. I forgot there's a second question. The domain here. The domain on this is going to be, again, keeping in mind that that right there is our solution. And so the question is this good for all x here? Remember, this worked for the initial condition of negative 1 to 1. Negative 1, 1, if you will, right? If we were to put a 1 in here, we should expect to get 2, but what's going to happen if we put a 1 in here? We're going to get negative 3, aren't we? Okay, so does this work on the right side of the slope field, if you will? Okay. We built it because we used a point on the left side of the slope field. Okay, so what's the domain that's going to make this one work? X less than 0. So it's only good for the left-hand side. If we were to, like I said, if we were to use this solution on the right side, it wouldn't match up with our slopes, would it? Okay. It would match up with our slopes on the left, okay, but it doesn't match up with the slopes on the right, so therefore the domain would be on the left side of the y-axis, which is x greater less than 0. Yeah?
I did something different. I plugged in the negative 1 and 1 into the derivative, and I wrote an equation out, and then I got the same answer. Like y minus 1 equals negative 2x plus 1.
Yeah, I mean, it's any differential equation. If you want to get all the points, they're going to want to see you do the separation of variables technique. Especially if you know it's worth 7 points. I mean, if you just wrote it, I mean, it worked out this time because it was linear. Okay, but that's not going to work out in most every other case. So anytime it's a differential equation, you got to find the solution. You need to do the separation of variables. Like I said, especially if it's worth 5, 6, 7 points, you know, they're going to want to see every step so you can get a point for every step. So, like I said, this one happened to be a pretty easy solution. It was linear, so you know you could write an equation that gave you the line that was the same as this in this particular case. But this is probably the only problem I've ever seen that would be that would work. All right. Anything else on number 5? All right. Let's take a look at number 6 then. We have a twice differentiable function f. And it tells us we have a function value, a derivative value, and a second derivative value at 3. And in part A here, it says that the g function is given by e, that is, e to the ax plus f of x. And it says a is a constant, and we want to find g prime at 0, find g double prime at 0 in terms of a, and show your work that leads to your answers. So, you know, again, this is a typical problem where some people are going to be like, I don't get it, man. There's like too many variables and whatnot, so let's quit. Okay? But, again, trust your calculus. If you want g prime here, okay, we know the function g, so finding the derivative isn't going to be any different than anything else that we do. Okay, what do we know about the derivative of e to the ax?
A times u to the ax.
It's itself times the derivative of the argument. What's the derivative of ax? A. So itself times the derivative of the argument. And what do we know about the derivative of f? We don't have a function for f, so really it's just f prime at x, isn't it? There is no function to differentiate, we just have to write f prime. That's the only thing we know about f. And we want g prime at 0, then ultimately I'd be putting a 0 in for x in all these spots. And so with that, this would be 0, so e to the 0 would be 1, so we'd get a. And then what do we know about f prime at 0? It's negative 4. So ultimately, what's the final answer then? A minus 4. It said write it in terms of a, didn't it? Okay. 1 point for finding the derivative. 1 point for finding the a minus 4. And second derivative, we do g double prime. And again, remember our g prime is right here. So if we were to differentiate that, we'd get a squared. E to the ax, because again it would be the e, the a is just a constant, so it would be the itself times the derivative of the argument again, and then plus f prime, double prime that is, I mean, derivative of f prime would be f double prime, and if we plug in our, by the way, you get a point for just doing that much, And if we plug in 0, we get a squared e to the a times 0 plus f prime, f double prime at 0. So we'd ultimately get a squared only here, and f double prime at 0 would be 3. Plug those in properly. A squared over 3, get one more point for that. Right. And on part B, we have the function h, which is defined as cosine kx times f of x. And we do similar stuff with that. We just need to find h prime of x and write an equation for the line tangent to the graph of h at x equals 0. So we know that if we're going to write this tangent line, before we write the tangent line though, we're going to need to find h prime anyway because we need the slope of h at that point. Alright, so if we want to find h prime, I'm going to recognize this as just a product rule problem. If I do product rule, that's going to be cosine kx times f prime x plus f of x times the derivative of cosine kx. The derivative of cosine kx would be negative k sine kx. So
When you divide by k, so we get 1 over k.
we're doing the derivative here, not the anti.
Oh.
Remember, we multiply by the derivative of the argument.
Yep.
It would be 1 over k if we were anti-differentiating, because we're doing the opposite. Alright, so with that being our derivative, we'd get a point for, actually we get 2 points for doing that, believe it or not. So 2 points for being able to do the product rule on that. And then ultimately we need h prime at 0 because we're writing a tangent line. So if we do cosine of 0 plus f prime at 0 plus f at 0, and then over here we get negative k sine of 0. Put those x's in there as 0s, those k's are going to be gone in those arguments. And so cosine of 0 we know is 1. What's f prime at 0? Negative 4. So that would ultimately be negative 4 right there, plus f at 0 is 2. And this is what sine of 0 is? 0, so that whole thing is 0. So the answer is negative 4, be our slope. And then from there, let's fill in the blanks. And the point in question is 0, so it'll be x minus 0. And the y value for our h function, remember this is an equation for the h function, right? So we need to put the x equals 0 in for h. So if we were to do that, we'd put 0 in here. If we did 0 here, we get cosine of 0, which is 1. And then f of 0 is 2. So it'd be 1 times 2, or 2. And that would do it. 5 points. 2 points, like I said, for finding the first derivative here. 1 point for finding the derivative at 0, which is the negative 4. 1 point for finding the 2. And then 1 point for writing the equation properly. And that'll do it. Questions?